So hi guys, welcome to my channel. Today I'm going to solve the another GFG problem of the day, which is sorted subsequence of size 3. Difficulty is medium. So let's read the problem, what it is trying to explain and how to approach this. So again, the code is looking very big, but it's not that big. And if you understand the approach, like how to approach this problem, then the code will be like very easy for you all to write it. So let's see. So you are given an array. You need to find three elements such that array of I less than array of j and less than array of k. So like basically we have to find the subsequence. Like it should not be in the like order. Like what it is trying to say is we can select 1, 2 and 3. Let's see. 1, 2, 1, 1, 3. If it would be like 1, 2, 3, then we can select it as like continuous elements, but it is not necessary to select the continuous element. We can select it as a subsequence also. So we will have to return like three elements which will be following these order, and if if the subsequence we have returned is correct, it will output 1. If it is not, then 0, or if it is not in the format, then it will output -1. So let's see how to approach this problem. So what we'll be doing here is we, for every element, because we can see the time complexity expected is big of n and space is also big of n, we can solve this problem using recursion, and further we can memorize it, but it will be, the time complexity will be around big of n square if we optimize also. So what we will do, we will use the concept of stack. Like what we will be doing, for every element, we will find that what is the smaller element to the left and what is the greater element to the right. For every element we'll be storing, and we will be like storing it in the left array and right array. Okay, so how will we do that? So let's see. So for 1, there is any smaller element to left? No. So it is -1. Now for 2, is there any smaller element to left? So yes, 1 is there. Now again for 1, is it smaller? Is there any smaller element towards left? No. For 1, no. For 3, what is the smaller element? It is 1. Okay. Now for right we will be seeing. So once again I'll be explaining that for left, when you start calculating for left, you will be starting from here. Why? Because you have to see that whether left of this any smaller element is present or not. Okay, now for right we'll be starting from here. Why? Because we have to see that in right whether there is the small greater element than this element is present or not. So this way we will be calculating right. So in right, is there any greater element? No. For 1 it is 3. For 1 again it is 3. For 2 it is 3. For 1 it is 2. Now we will start iterate a loop from array of I like till the last index, and we'll be seeing that we'll check one condition, that if left of I is not equal to -1 and right of I is also not equal to -1, then we will return our answer. Like if left of I is not equal to -1, no, this is not the case. If left of I, right of I not equal, yes, this is the case. So what we will do, we will first push 1 in our answer, then we'll push 2 in our answer, then we'll put 3 in our answer. Why? Left array of I, then right, and we will be breaking our loop and return, because we got our answer. Here is also not possible because in any of the one we got -1. Here also not, because -1. Here also not -1. What -1 is showing that there is no left element which is smaller, or if in right we got -1, means there is no right element which is greater. So here also, so this is how we are approaching this problem. Now how we are finding that left element smaller to that or not, smaller to current element or not, we'll be using stack. I'll be doing dry run of finding left, and right one is very similar, just I have told that instead of starting from first index, we'll be starting from last index. Rest everything is same. So let's see how we have find the left. So let's say we make a stack. Okay, so and one answer vector. So let's see from left. So if at the beginning, if left is empty, means the stack is empty, then we'll push -1 to the stack. Sorry, not -1 to the stack, -1 to our answer, and the current element to the stack. Why? Because there is no element to in the left of that current element which is smaller than the current element. So we have pushed -1 to our answer and finally pushing 1 to our stack. It is stack. Now we'll move to second element. So second element is 2. We'll see that if second element, if the stack top is less than the current element. Okay, so yes, 1 is smaller than current element, then we'll push it in our answer 1, and we will be finally pushing 2 in our stack. Now coming to current element 1, we will see in the stack top if it is smaller than like the current element. No, sorry, 2 is greater than the current element, so we will pop it. Now again we'll see if it is smaller. No, it's not smaller, then again we'll pop it. And if check that if stack becomes empty, then we'll again push -1, and we'll be pushing 1 to our stack. Now coming to 1, we'll check that if stack top is less than 1. No, it is not, so we'll be popping the element, and finally we'll be pushing. If stack becomes empty, then we'll push -1. I'll be writing all the steps, don't worry. So now I'll be pushing 1 to our stack. Now coming to 3, if stack top is less than like the current element, yes, so we'll be pushing 1 to our answer and finally pushing 3. Now our like array got the desired output. Now what is the step? So while we are standing on the current element, let's say in this, we'll check that if stack is empty. If initially stack is empty, directly push -1 to our answer. Now if stack is not empty, stack is not empty, if stack is not empty, then check that if stack top is less than current element, means the array of I in which you are currently standing. Now we will check that if stack top is less than, then push. If it is so, then push stack top to our answer. Now if stack top is greater than or equal to current element, means we are standing at 2 and we are getting 3. I'm just giving an example. So we will pop the element from the stack until and unless we get the smaller element at the top of the stack or the stack becomes empty. I'm repeating again. If I'm standing at the element 2 and we are getting the like 4, 5, 6, so we will pop the element from the stack until and unless the element in the stack is smaller than the current element or the stack becomes empty. If the stack becomes empty, we will again push -1, or if we get the smaller element at the top of the stack, so we will push the top element of the stack to our answer. So this is the way we are calculating the left, and we are calculating the similarly we are calculating the right. Only the change in the right is we will be starting from here, and we will check that the conditions become same. Like I'll be copying it for right, and some steps will be okay, will be changed. So what are the steps that is changed here is this will become greater than, not this will become less than. Okay, why this will become greater than? If stack top, because because while calculating right, we'll be seeing that if there is the element at the stack top which is greater than the current element, then we will push it in our answer. Like here, if stack top is greater than current element, then push array of I stack top in our answer. And when we will be popping the element from the stack, when we get the stack top which is less than 3, like we are having 3 and we are getting 1 2 4, so stack top is less than 3, then we don't need less than 3, again don't need, yes, greater than 4, then we'll be pushing 4, because in right we have encountered an element 4 which is greater than 3, so we'll be pushing this. So this is how right is working, and at last we will be reversing the answer vector. Why? Because while standing on 3, we'll be pushing in our answer -1, then 3, then 3, then 3, then 2, like this only, but it in the reverse order. Why? Because we have iterated from the last. So at last we'll be reversing our right answer while traversing to like while finding the right array element. So let's see the code. So I have done very simple things. I have initialized two vector left and right. I have called next smaller to left and passed left. I have called next small greater to right ngr and passed right. I have created one answer vector where I will be storing all the three elements which follow the current like condition, and I'll be iterating all the element in the array and check that whether left of I is not equal to -1, means there is the left element present in the left array which is smaller to the array of I, and right of I is also not equal to -1, means there is possible element like which is present to the right of that current element. Then we'll be do like answer dot pushback. First I'll be pushing left element, then I'll be pushing the current element, then I'll be pushing the right element, and then finally break it. Now let's move to the next smaller to left. What we'll be doing in next smaller to left is we have initialized a stack. Now for while calculating the left vector, we'll be starting from the first index. So if stack is empty, again I have told that push -1 to our left. Now while finding the smaller element towards left, we'll be seeing that if stack top is less than arrow 5, I have said that if stack top is less than arrow 5, then we'll be pushing directly the stack top, like here I have explained. Sorry, this case stack top is less than arrow 5, then we'll be pushing stack top to our answer. Now else if stack top is greater than equal to arrow 5, means we got the element which is greater than to the current element, so we'll be popping the elements from the stack while these two conditions were like meeting. If stack is not empty and stack top is greater than equal to arrow 5, then pop the elements. Like if we came out of the while loop, then it must be like in any of the two conditions will be failed. So if stack becomes empty, then we'll be push -1, or if in the top of the stack we got the element which is smaller than the current element, again if we got the element on the top of the stack which is smaller than the current element, then we'll push the stack top in our answer, and at last we'll be pushing the like current element to the stack. Similarly, next greater to right, we'll be starting from back side and we'll be moving towards left, and if stack is empty, push -1. If stack top is greater than arrow 5, because we want greater elements towards the right, so we'll be pushing directly to the stack top. Now if we got the stack top less than equal to arrow 5, means we got the element at the stack top which is less than arrow 5, we don't need, so we'll be again like running a while loop. And if we come out of the while loop, if stack becomes empty, directly push -1. If stack is not becomes empty and we got the element which is greater than the current element, then we'll be pushing stack top to our right answer, and finally stack like pushing the current element towards the stack inside the stack. Now at last what I've told that to reverse the like right array. Why? Because we have iterated from right side and we have pushed the element from right side only, so that's why reverse it, and finally the function calls, and let's run. Okay, we got the output, and let's submit it. Okay, so it has passed and time taken 0.25. So I hope the question is clear and the approach is also clear, and I hope I have explained the questions well and you all can write the code by your own. So thank you for watching. That is it for the day.